So if you did yesterday's, you may recall that something like this, and what we were doing was looking for factors. Factors are things that multiply together to give us this. And what you should do is look for something common in all of those. Is there anything common in all of those? No, right? There's no common factor. This one only has x's, but this one doesn't have x's, so there is nothing common in all of those. If there's nothing common, then the only other way you could factor this is with binomial factors. So you have to start here, remember? And you ask yourself, what times what would give me x squared? What times what gives me x squared? It has to be x and x. Wouldn't you agree with that? There's no other possibility. It has to be x times x. Then we go down here. And now you want to know, what are two factors that would multiply to give us 36? Well, I like to list them all. 2 and 18, 3 and 12, 4 and 9, 6 and 6. Of those, remember, we decide which pair to use by looking, we want the pair that's going to add up to this. The pair that's going to add to 13, right? That's what you did in yesterday, or the assignment we just corrected. So you've got to go down the list and see which of these pairs is going to add to 13. Does this add to 13? Does this one? Does this one? This one? Ding, ding, ding. And then, you know what I always like to do is check the others just to make sure. This one's not going to. Sometimes there might be two that actually work. So 4 and 9 add to 13. So there you go, 4 and 9. The only other thing you need to figure out now are the signs. And remember, from the assignment from yesterday, what we want is a positive. How do you multiply these two numbers together and end up with a positive sign? How do you multiply two things together and get a positive answer? Negative times negative, or? Right. It's got to be negative times negative or positive times positive. That's the only way you can multiply. Negative times negative gives me a positive, and positive times positive will give me a positive, right? To figure out which, then you look to the middle sign. Since it's positive, you know those have to be positive, positive. Finally, just to double check, inside, outside, double check. That's what I told you to do, the inside, outside double check, where you multiply these two together. What's positive 4 times x? Positive 4x. And then you do the outside, positive 9 times x, and you add those up. It better equal this middle number. Does it? Yes, that's the inside-outside double check. And if you look at the problems you did yesterday, most of them, well, it was supposed to be all of them, but I screwed up. That shouldn't surprise you by now. But all of them except for 1 or 2, this first value was 1x squared, 1a squared, 1n squared. There was no coefficient on that first term. Well, today we're going to look at factoring if there is a first term. And the easiest thing The easiest thing is to look and see if there is anything in common. Look at these, 2, 26, 72. Is there anything in common with those? What, John? There's a 2. There's a 2, right? So what we want to do, if there is anything in common, is to take it out right away. 2 times what is 2x squared? 2 times what is 26? 2 times what is 72? And once you take it out, then what you have here, you have to see if you can factor that. Can you factor that? Because that's the one I just did right here. Just did that one. So do I have to do it again? It'll factor into x plus 4, x plus 9. So sometimes you'll be able to take out a common factor. Not always. If you look at this one, can I take anything common out of there? Can I? Can I? No. Nothing common. So the next thing I have to try is this. But yesterday, the first thing, it was always an x squared or an a squared. What times itself has to be x and x. But down here, it's not x and x anymore. I have a 5x squared. How do I multiply numbers together and get a 5? What number? 5. 5 times 1, right? To get a 5 there, it has to be a 5 times 1. Agree? And it's an x squared. So would you agree I have to have a 5x and a 1x? I don't care if you put that 1 there or not. It's up to you. But would you agree to multiply and get 5x squared, it has to be 5x times 1x? Then we're going to move down to the other end, just like we did yesterday. How do I get a 1? Ooh, that's easy. Has to be 1 times 1. There's no other possibility. How do I get a positive? What am I going to multiply together to get a positive 1? 2 positives or 2 negatives, right? That's what you practiced with yesterday. And since the middle is a positive, and now you're going to do the inside-outside double check. What do you get here?
7.
Oh, yeah, what do you get here? 5x, positive. And what do you get here?
1x.
Oh, this is going to be a great day. Does that work out? You know what that means? 2 things. That means 2 things. The first thing it means is it's got to be prime. The second thing it means that's not what I wanted. I don't want to start with a prime one. I'm a dingbat.
1 times 1x squared.
1 times 1x is right here.
Yeah.
It's 6x, and guess what? Right, thank you. Thank you. Oh, well, moving right along here. Everybody agree that one has to be prime? Because even though everything seems to work out, 5 times 1 is 5, and 1 times 1 is 1, when you do the inside-outside double check, guess what? It does not double check. And we only had one possibility here, one possibility here, but yet it doesn't give us what we need in the middle.
The one was negative.
Negative.
That's how it is in
Right.
the book.
Right. If the one was negative, and that's how it is in the book, and I screwed it up. Well, so do you see how it's important, though? Because you're going to have some of these that seem like they work out, but they really don't. And when you do the inside-outside double check, it doesn't come out, so that means it's going to be prime. So let's keep going. Let's keep going. Right here. Again, I have a 2x squared. There's only one possibility for a 2x squared, right? What is it, John? 2x times 1x. Has to be 2x times 1x. Then if you go down to the end, 3 has to be 1 times 3. But here's the thing. We want the inside-outside double check has to add up to 5. So what you have to be careful of is, it makes a difference. This is 1 and 2, and this is 1 and 3, but it makes a difference if it's 1 and 3 or 3 and 1. And you have to figure out which one goes where by doing the inside-outside double check. What do you get here? 1x. What do you get here? They have to subtract to 5. Do they subtract to 5? Well, yes, and then we're going to put the signs in. Because it's a negative here. How do I get a negative? Has to be one of each. Has to be a positive and a negative. Remember yesterday's assignment, the bigger one of these got whatever's in the middle. Well, because we have a number out here now, you want now the bigger of these combinations. So this is the biggest combination. That one has to be the positive. This one has to be the negative in order to get a positive 5 here. How do I make it so that this combination is a positive? The positive goes here, and so that means the negative goes here. Right? Oh, this is a lot of work. How about this one? It's got to be 3a and 1a, doesn't it? And this one has to be a 1 and a 5. But remember, I want the combination that will add to 8. If I do this, if I do a 1 and a 5, that's going to give me 15a and 1a in the middle. Is that combination going to add up to 8? No. So you have to be careful where you put them. So if that combination doesn't add up to 8, then we're going to have to swap them and put the 5 here and the 1 here. Does that add up? What do I get here? 5a, and here, 3a. Does that add up to 8a? But actually now, the signs, be careful, the signs, it's positive, that means it's either positive, positive, or negative, negative. So they're both going to be negative. Negative 5a, negative 3a, that's going to give me a negative 8a. Does that make sense? Does that make sense? Does that make sense, Jaden? Oh, good, 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 good. How about this one? How about this one? I'll do this. It's got to be 2x and 1x. 21 could be 1 and 21, or it could be 3 and 7. Now there's 2 possibilities. And remember, when you have a number out here, it's got to be the inside-outside combination that subtracts to 1. I need the combination that's going to subtract to a 1. Remember, there's a 1 there. So what do you think? Should we start with 1 and 21?
No, just 2.
She says start with 3 and 7. Anybody agree with her? Good. Agree with her? So start with 3 and 7. Is that going to give me 1 in the middle? This will be 14x, and this will be 3x. Does that work, John?
No, you gotta swap them.
No, you got to swap them. And these are going to be just a little bit more trial and error. Not so sure. And then if you're like me, you'll forget which one you had where, and you'll try the same combination again. That's wrong. That's wrong. I think I need to go take a nap. Now, what do I get here? 7x. What do I get here? 6x. Will that subtract to 1?
Yes.
Yes. Now we need to get the signs. I have a negative here. That means I'm going to have a positive and a negative. So the bigger one is positive, but now it's got to be the bigger combination. This is the bigger combination, and it has to get the positive. So what does that mean? What goes here then?
Positive.
Positive?
Yeah.
He says positive, positive, so that means this one's negative. That'll give me a positive 7, negative 6. That'll add up to positive 1. Do I have any questions so far?
Yeah.
Oh, do you remember how much fun this was?
I remember doing this in like
5th grade? Where'd you go? The Menominee School of Geniuses? You did this in 5th grade?
I have a vague memory.
Right, of course you did. You did it with me. Yes, you did do it with me. Back in the good old days. First hour algebra. Now, nobody has questions yet? I'm going to make your life just a little more difficult. Cover that up. I don't want to see that.
What?
It's bad enough I have to look at your bare knees.
Yeah.
Your midriff skin. I don't want to see that. I don't want to see that. I have a 15. Uh-oh. Uh-oh. 15 could be 1 and 15, and it could be 3 and 5. And I go to the other end. 4 could be 1 and 4, and it could be 2 and 2. Oh. Hey, look at the signs. It's positive. How do you multiply two things and get a positive? It's either plus, plus, or minus, minus. Since this is, hey, look at that. I know it's got to be minus, minus. Oh, but it might take us a little bit longer to figure out the first one. I need the inside and the outside hey, that kind of looks like a face, doesn't it?
Yeah.
I need the inside-outside combination to add up to 16. This could be 1 and 15. It could be 3 and 5. The second one could be 1 and 4. Could be 2 and 2. Here's where you might have to do a little trial and error. What should we try first?
3 and 5.
What do you say?
3 and 5.
He says 3 and 5. Why did you pick 3 and 5? Any special reason?
Because I think I figured it out.
He thinks he's figured it out. So he says maybe 3t and 5t. And then what? And then what? What do you think, Marshall? Is he right? He is right? What else, John? If it's 3 and 5, what else do you want?
1 and 4.
1 and 4?
Yeah.
1 and 4? Going 1 and 4?
Oh, wait, no. Crap.
4 and 1? Oh, he says, wait, no. Here, let's try it. 4 and 1. That's going to give me 20t, and this will give me 3t, and they have to add up to 16, do they? Not that way. Let's try flipping it. Let's try doing, don't forget which you had where. Let's try doing 1 and 4. That gives me 5t and 12t. Whoops, what is that? Does that add up to 16?
Just barely no.
Probably not, but close. So now what do? We tried 1 and 4, that doesn't work.
2 and 2.
Try 2 and 2.
Well, it's
And unfortunately, this is going to be a little bit of trial and error. So now we'll try 2 and 2. I get 10t, and I get, well, actually, this is negative 10t, and that's negative 6t. How's that?
yeah.
That one works. And you know what? If 2 and 2 didn't work, then you'd probably have to go back and change these to 1 and 15. Sometimes there's a little bit of luck. Sometimes you'll hit it right on the first time. Sometimes you'll erase and erase and erase. Does that make sense? Do you have questions? Should I do any more?
Are we gonna have any more of like those ones with multiple variables?
Definitely.
Multiple variables. You might have one with multiple variables, but you know what? It's no big deal. If it were, like, let's say if it were 2x squared plus xy minus 21y squared, the variables kind of just go along for the ride anyway. You know, this has to be 2 and 1, and the only way to get an x squared is x times x. Down here it's a y squared. The only way to get y squared is to do a y and a y. And then you can figure out what multiplies to 21 and gives you a 1 in the middle, right? So it's exactly the same. X times x is x squared. The only way to get a y squared is y times y. Easy, right? Not bad. Do you have any questions? Well, let's get rid of this. Anybody with questions? Are there any questions? Does anyone have a question? Anyone? 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 22 to 58.
Maybe 23.
Okay, 23 to 58. How about 23 to 39? Page 191. 23 to 58. What did I say? 23 to 39. You should be able to handle that, shouldn't you? Oh. Did I ask if anyone had questions? Does anyone have a question? Put your papers in the basket when you get a minute.